Okay, so you want to own a waste treatment plant. Garbage trucks arrive before sunrise. Every city produces waste every day, and every load needs somewhere to go. It sounds like the ugliest toll road in the world. That is the dream. The problem is that garbage is not a single product, and a waste treatment plant is not just a big machine that charges trucks at the gate. It is a permitted industrial system that takes society's most inconvenient material, separates the parts that still have value, burns or treats the parts that can be destroyed, controls the pollution that this process creates, and then finds somewhere legal to put whatever is left. From the outside, the business looks protected. Nobody wants a competing plant next door. Local governments need disposal capacity. Industrial customers need a legal endpoint for materials they cannot keep on site. A plant with permits, contracts truck access, grid connection, trained operators, and community approval can feel like a miniature monopoly. Ownership begins with that comforting thought. People keep producing waste in good economies and bad ones. Restaurants throw out food. Households fill bins. Hospitals, factories, laboratories, warehouses, construction sites, and shopping centers all produce streams that need collection, sorting, treatment, recycling, combustion, stabilization, or disposal. Somewhere in that flow, it appears, an owner can stand at the gate and charge by the ton. The first reversal arrives before the first truck enters. You are not really buying garbage. You are buying permission to touch garbage in a specific way, at a specific site, under specific limits, with a balance sheet strong enough to survive when the waste is dirtier than expected, the plant shuts down, the ash has nowhere cheap to go, the power price falls, or the local community decides the smell trucks and emissions are no longer tolerable. A waste treatment plant is easiest to understand as a toll booth attached to a chemistry problem. The toll booth is the tipping fee, the price charged when a hauler brings waste to the facility. The chemistry problem is everything that happens after the gate closes. Mixed waste contains food, paper, plastic, glass, metal, soil, batteries, liquids, pressurized containers, treated wood, medical residue, and sometimes material that was never supposed to be in the truck. A landfill can bury some of that. A recycling plant can recover part of it. A composting or anaerobic digestion facility can handle selected organics. A hazardous waste facility can treat particular dangerous streams. A waste-to-energy plant burns residual municipal waste, turns heat into steam, and uses that steam to make electricity or heat. This video is about the owner who wants the more industrial version of that business, a large treatment plant, especially the waste-to-energy and advanced disposal model that cities use when land is scarce, regulations are tight, and waste cannot simply be dumped cheaply forever. The visible asset is a building with a tipping floor, cranes, furnaces, boilers, scrubbers, turbines, conveyors, control rooms, ash handling, wastewater treatment scales, truck lanes, and maintenance shops. The hidden asset is a portfolio of permissions and contracts. The permission comes first. In the United States, a municipal waste combustor is regulated under the Clean Air Act, and EPA rules for large municipal waste combustors apply to units burning more than 250 tons per day. Those rules focus on pollutants such as particulate matter, carbon monoxide, dioxins and furans, sulfur dioxide, nitrogen oxides, hydrogen chloride, lead, mercury, and cadmium. If hazardous waste is involved, the gate becomes even narrower. A treatment, storage, and disposal facility needs a RCRA permit from the EPA or an authorized state agency, and the permit has to define what the facility may handle, how it monitors emissions in groundwater, what corrective action is required if contamination appears, and how closure will be funded when the site stops operating. That last detail is easy to overlook because closure happens at the end of the asset's life. Lenders do not overlook it. Regulators do not overlook it. A waste plant can earn money for decades and still leave behind ash residues, contaminated equipment, tanks, pads, liners, wastewater systems, or soil problems that have to be managed after revenue stops. Financial assurance is the rule that forces an owner to prove that someone will have money to close or clean up the facility, even if the operating company is weaker later. In plain English, the owner has to set aside credibility for a future bill that may arrive after the business stops being attractive. Before revenue, there is land. The site has to be close enough to waste generation to avoid expensive trucking, but far enough from voters' homes, schools, and political pressure to survive permitting. It needs road access for heavy vehicles, enough buffer land, water and sewer connections, grid interconnection if electricity will be sold, and geotechnical conditions that can support heavy equipment and foundations. The best site is near the waste, near infrastructure, and far from outrage. That combination is rare. Then the owner starts buying the actual machine. A tipping hall by itself is not the expensive part. The serious money goes into cranes that feed the waste combustion lines, or treatment trains, boilers, turbines, air pollution control systems, scrubbers, baghouses, continuous emissions monitoring, wastewater treatment, ash conveyors, fire protection, odor systems, spare parts, control software, and redundancy. EPA's own public guidance says a new municipal solid waste combustion facility typically requires at least $100 million to finance construction, with larger plants needing 2 to 3 times that amount. In today's financing environment, once engineering, land, interconnection, permitting, contingency, interest during construction, owner's costs, and startup losses are included, a serious regional facility can easily become a few $100 million commitment before the owner knows whether the waste stream will behave. Financing creates the first structural trap. Cities and private developers like these plants because they solve a physical problem. Bond markets and infrastructure funds like them when there is a long-term waste contract. Lenders see daily garbage collection and imagine stable volume. The danger is that the plant's debt service starts on a schedule, while the plant's operating performance may not. Construction delays, failed commissioning tests, community challenges, or technology problems can make interest accumulate before the facility earns its first dependable dollar. The entry price is also not just money. A plant needs a waste supply agreement. Without it, the owner has built an expensive mouth with no guaranteed food. A municipality may promise to deliver a minimum number of tons per year or pay for capacity even if it sends less. That sounds wonderful until the contract is read closely. The city may have price protections, political leverage, recycling targets, contamination rules, renewal options, or termination rights. A private hauler may send waste only when your gate fee beats the landfill. Industrial customers may pay high prices for difficult material, but that revenue arrives with more documentation, more liability, and more risk if a shipment is mischaracterized. The revenue stack begins at the scale house. Trucks are weighed in, dumped, and weighed out. The difference is the tonnage, and tonnage becomes the first invoice. A tipping fee may be the heart of the business because it pays the plant to accept material that someone else needs to remove. In a dense region with high landfill costs and limited disposal capacity, this fee can be powerful. In a region with cheap landfill space, it is under constant pressure. Electricity is the second layer. The heat from burning waste creates steam, and steam can turn a turbine. EPA says a typical waste-to-energy plant generates about 550 kilowatt-hours per ton of waste. And at 4 cents per kilowatt-hour, that is often $20 to $30 of revenue per ton. EIA reported that as of May 2026, U.S. power plants burning municipal solid waste generated about 12.8 billion kilowatt-hours from roughly 26.6 million tons of combustible waste. Those numbers make the energy layer visible, but they also show its limit. The plant is not really a power plant that happens to burn trash. It is a waste disposal facility with an energy business attached. Metals form the third layer. After combustion, magnets and separators can recover ferrous and non-ferrous metals from the ash stream. That scrap can be sold, and in some years, it quietly improves the margin. Commodity markets decide how much help it provides. A strong metal price turns residue into revenue. A weak market turns the same equipment into a smaller offset against the cost of handling ash. Special waste and industrial services can become a fourth layer if the facility is permitted and designed for them. Some customers will pay far more than ordinary municipal gate fees to have sludge-contaminated materials, chemical residues, or difficult waste treated properly. The attraction is obvious. Hard-to-handle material brings better pricing. The catch is that every step demands tighter characterization documentation, trained labor liability control, and sometimes a completely different permit. There can be other revenue streams around the core. Some plants sell steam or heat to nearby industrial users. Some sell renewable energy credits or environmental attributes where rules allow them. Some recover water, process wastewater, or market alternative fuels. Certain operators package compliance services, collection, transport, lab, packing, emergency response, and disposal into one customer relationship. The more integrated the company becomes, the less it depends on one gate fee. The business starts to look less like a single plant and more like a network. The cost machine is less flexible. Labor is required whether the gate fee is high or low. Control room operators, mechanics crane operators, maintenance crews, safety teams, lab technicians, environmental managers, scale house employees, drivers, engineers, accountants, and security all have to show up. The boiler does not care that commodity prices are weak. The emissions equipment still needs lime, activated carbon, ammonia or urea filters, electricity, water, spare parts, calibration testing, and inspections. Fire systems cannot be skipped because waste piles can burn. Insurance does not disappear because the plant is unpopular. Debt service does not shrink because one municipality delivered fewer tons. Ash is one of the strangest costs because it proves that even destroyed waste does not fully disappear. EIA explains that waste-to-energy plants can reduce 2,000 pounds of garbage to ash, weighing about 300 to 600 pounds, and can reduce volume by about 87%. That is useful, especially where landfill space is scarce. Still, the owner must handle the ash, test it, recover metals where possible, and dispose of the remaining residue. EPA notes that ash from municipal solid waste combustion generally ends up in landfills, so the plant that was supposed to reduce dependence on landfills still needs a landfill relationship at the end of its own process. The central trap is now visible. Revenue depends on tonnage pricing, power markets, recyclable values, and customer contracts. Many costs depend on physics law, safety, debt maintenance, and public trust. When volume is high and contracts are favorable, the plant can look like a protected cash flow machine. When one variable breaks, the same fixed structure can turn the owner into the last person responsible for everyone else's waste. This is operating leverage. In plain language, the plant has a large base of costs that do not move much in the short term. A small increase in revenue can flow through strongly because the furnaces, permits, staff, and control systems were already paid for. A small revenue decline can hurt just as quickly because the same obligations remain. The machine magnifies both the good year and the bad year. The failure case becomes clear in Tees Valley in the United Kingdom. Air Products, an experienced industrial gases company, did not enter the waste-to-energy business as a naive buyer of a small local plant. The company pursued advanced gasification projects that were supposed to convert waste into energy through technology more complex than conventional mass-burn incineration. In a 2015 SEC filing, Air Products said it had invested about $1 billion into 2 waste-to-energy projects in Tees Valley that relied on processes not yet commercialized at the same scale or in the same combination. That sentence contains the entire risk. The project was not only a waste contract or a power asset, it was a scale-up bet. The owner needed the waste to arrive, the technology to work, the construction budget to hold, the commissioning process to prove stable, the offtake economics to make sense, and the financing to survive the time between promise and performance. A conventional plant can fail, but a first-of-its-kind technology adds a second business proving the machine. By April 2016, Air Products announced that it would exit the energy from waste business. The company expected a pre-tax charge between $900 million and $1 billion in discontinued operations, primarily to write down assets associated with the business. The public explanation pointed to design and operational challenges. That was not a small miss. It was a reminder that in waste treatment, a facility can have demand for its service and still fail if the process cannot run reliably at commercial scale. The lesson is not that every advanced waste technology is doomed. The lesson is that the owner cannot finance a science project like a boring utility. A truck contract does not make a furnace work. A power agreement does not eliminate commissioning risk. A municipal need for disposal does not remove the cost of downtime. When investors assume that garbage volume is the same thing as plant performance, they confuse demand for the service with reliability of the asset. Harrisburg, Pennsylvania offers a different version of the same warning. The city's resource recovery facility became tied to hundreds of millions of dollars of debt, and by 2011, official recovery documents described more than $200 million of principal bonds outstanding on the facility, and annual debt service above $18 million. Reporting at the time described the incinerator debt as a central force behind the city's financial distress. This was not only an engineering problem, it was a municipal finance problem wrapped around an industrial plant. The decision once looked reasonable. Modernize a facility, handle waste locally, recover energy, and turn a city service into a source of value. The variable that changed was not one simple market price. Costs rose, debt accumulated, operating performance could not carry the financial burden, and guarantees moved the pressure from the facility to the city. The broader lesson is brutal. When the owner of a waste plant is a municipality, a failed capital structure can become a civic crisis. Success looks different because the best operators do not treat the plant as an isolated bet. They build networks. Reworld, formerly known as Covanta, describes itself as operating more than 90 thermomechanical treatment material processing and recycling facilities. Its 2025 public sustainability materials say it managed 19 million tons of waste, recovered 432,000 tons of metal recycled or reused, 250 million gallons of wastewater, and generated 8.7 million megawatt equivalents of energy. Those figures matter because they show several revenue and value streams moving through one platform rather than one machine depending on one assumption. Clean Harbors shows the same idea from the hazardous and industrial side. In its 2025 annual report, the company said it operated 10 commercial hazardous waste incinerators, 7 landfills, and a broad network of treatment, storage, and disposal facilities in North America. It served more than 350,000 customers and reported $6.03 billion of total revenue in 2025. Its environmental services segment generated $5.19 billion of direct revenue and $1.34 billion of adjusted EBITDA, with adjusted EBITDA meaning earnings before interest, taxes, depreciation, and amortization after certain adjustments, rather than the same thing as net income or cash flow. That success did not come from the idea that waste is easy money. It came from permitted scarcity, customer relationships, logistics, trained labor, compliance systems, emergency response capability, and a network that could absorb volume across different facilities. A factory with a dangerous waste stream does not only want a low price. It wants documentation, legal finality, reliability, and a counterparty that will still exist if regulators ask questions later. That is why a permitted disposal network can have pricing power, even when the material it handles is unpleasant. Bargaining power still cuts both ways. A city can become the anchor customer that makes a plant financeable, but the same city can also become the political actor that fights price increases. A power buyer can purchase the electricity, but often at wholesale or contract prices the plant cannot control. A regulator can approve the permit, then tighten monitoring requirements later. Nearby residents can challenge expansions or demand emissions data. A landfill competitor can undercut pricing if disposal capacity is abundant. The owner may feel protected by permits, but the plant survives inside a circle of stakeholders with different forms of leverage. Now run a simple owner model. These figures are illustrative, not the reported results of one specific company. Imagine a regional waste-to-energy treatment plant designed to process roughly 1,500 tons per day, and about 500,000 tons in a normal year after planned downtime. At an average gate fee of $95 per ton, the facility collects about $47.5 million from waste acceptance. Electricity adds another layer. If the plant produces roughly 550 kilowatt-hours per ton and sells power at an average realized price of 4.5 cents per kilowatt-hour, the energy revenue is about $12.4 million. Recovered metals, special waste fees, capacity payments, and other services add perhaps $10 million. Total revenue lands near $70 million. The cost side starts eating immediately. Labor, benefits, maintenance, reagents, utilities, testing, ash handling, environmental staff, insurance, property taxes, security, administration, and third-party disposal might consume $43 million. A prudent owner also reserves perhaps $8 million for major maintenance and periodic overhauls because boilers, turbines, cranes, and emissions equipment do not forgive underinvestment. Before financing, the plant produces around $19 million of cash-like operating surplus. That sounds healthy until the capital structure arrives. Suppose the project cost $350 million and was financed with 55% debt. At an interest rate near 6.5%, annual cash interest on roughly $193 million of debt is about $12.5 million before any scheduled principal repayment. Add $5 million to $7 million of amortization or required debt service reserves, and the equity owner may be left with only a modest pre-tax cash return in a normal year. The plant is open, the trucks are coming, and the furnace is running, but the economics are not a cartoon pile of money. They are a negotiation between gate fees, uptime maintenance, and debt. Change one variable, and the picture shifts. A recession reduces commercial waste recycling programs pull more combustible material out of the stream. Landfill competition caps the gate fee, and power prices fall. Instead of 500,000 tons, the plant takes 425,000 tons. The gate fee revenue drops to about $40 million. Energy output falls with volume, and the realized power price slips, bringing electricity revenue down toward $8 million. Metals are weaker too. Total revenue may fall from $70 million to roughly $56 million. Costs do not fall the same way. The control room is still staffed. The scrubbers still run. Insurance permits testing, maintenance, and security remain. Ash still needs a destination. Maybe operating costs fall from $43 million to $39 million, and major maintenance can be delayed only so much before reliability suffers. Debt service remains around the same level. A normal year cash cushion can disappear, and a plant that looked stable can move into negative cash flow without a dramatic collapse in physical demand. The future makes the business more important and more difficult at the same time. The World Bank's What a Waste 3.0 describes a future where global waste generation remains a multi-billion-ton problem even under better management scenarios. More waste means more need for controlled infrastructure. At the same time, public tolerance for emissions is falling. Landfill methane is under more scrutiny. PFAS and other persistent chemicals are changing what customers and regulators expect from treatment and recycling. Automation is improving the ability to pull value from the stream before residual waste reaches the furnace. Artificial intelligence and optical sorting may help the owner by reducing contamination, recovering more metal and recyclable material, and improving fuel consistency. Those tools can also hurt the owner if they remove high-energy material from the waste stream, leaving the plant with wetter, lower-calorie residuals that are harder to burn efficiently. Extended producer responsibility laws can push packaging companies to fund recycling systems, but that may reduce the volume available for disposal. Carbon policy can make landfill methane more expensive, but it can also make combustion emissions more controversial. Every green change creates a new contract question. That is why the best waste treatment plants of the future may look less like standalone incinerators and more like integrated resource hubs. Trucks arrive with mixed material. Sorting systems recover recyclables. Organics move toward composting or anaerobic digestion where possible. Residual waste goes to energy recovery only when better options are exhausted. Hazardous streams move through specialized treatment, wastewater is treated and reused, metals are recovered. Digital tracking proves where the material went. The owner is no longer just selling disposal. The owner is selling certainty. None of this means a waste treatment plant is automatically a good or bad investment. Financing, location, regulation, technology, feedstock contracts, community acceptance, energy prices, commodity prices, and operator skill can change the result. The figures in this script explain the machine and historical cases. They are not personalized financial, legal, accounting, tax, or investment advice. In this business, the same gate fee can be a safe cash flow for one owner and a debt trap for another. Return to the fantasy. The trucks still arrive before sunrise. The city still needs somewhere for the waste to go. The scale still turns tonnage into invoices. From far away, the plant still looks like a toll booth that nobody wants to compete with. Up close, the machine is different. You thought you were buying garbage. What you were really buying was permits, chemistry, public trust, fixed costs, debt service, emissions control, ash disposal, customer contracts, and the legal responsibility to make society's waste disappear without pretending it is gone. That is the economics of owning a waste treatment plant.